Assalamualaikum and good morning. Today we're going to present about dynamic group project. We are from group 3 and our topic is dynamic analysis of car braking system. This is our group member. The first is Justin Blair anak Balion. Second is Izani binti Ruslan. And then me, Muhammad Fidaun bin Rahman. And then Muhammad Al-Habib bin Badrul Hisham. And lastly is Muhammad Ammar bin Abdul Halim.
Braking performance is one of the most important safety features in a vehicle because it directly affects the driver's ability to control the car and avoid accidents. The effectiveness of braking depends on several factors such as vehicle mass, speed, braking system, and especially the interaction between the tires and the road surface. In this case study, we analyze the braking performance of Pro 2 Asia, which has a mass of approximately 1,400 kilograms. The vehicle is assumed to travel at an initial speed of 3 meters per second on a flat road and decelerates uniformly until it comes to a complete stop. From the mechanical dynamics perspective, braking is governed by Newton's second law of motion. The dominant horizontal force during braking is the friction force between the tire and the road, which opposes the vehicle's motion and causes deceleration. Since the friction and normal force are assumed constant for each road condition, the deceleration is uniform, allowing the use of kinematic equation. Two road conditions are considered, dry and wet, with friction coefficient of 0.7 and 0.4 respectively. By calculating the deceleration and stopping distance for each condition, we can observe how road surface friction significantly affect braking performance and vehicle safety. This study demonstrates how mechanical dynamics can quantitatively describe braking behavior and highlight the importance of road condition, especially in wet environment. The objective of this case study, firstly, to evaluate the braking performance of a Pro 2 Asia by measuring its deceleration and stopping distance during braking. Secondly, this study aims to illustrate the mechanical dynamic of braking using Newton's second law of motion together with kinematic equation. Thirdly, we investigate how different road conditions, specifically dry and wet surface, affect braking behavior by comparing their coefficient of friction. Next, we compare the braking performance on dry and wet roads in terms of deceleration magnitude and stopping distance. We also aim to validate the theoretical analysis by comparing the predicted result with experimental data. Finally, this study emphasized the critical role of friction in improving braking effectiveness and reducing stopping distance under various driving conditions.
Now, I would like to talk about the case study. This case study studies the braking performance of a Pro 2 Asia on a dry road and wet road surfaces. The car is chosen because it is common small city car used every day. The vehicle is assumed to have a mass of 1,400 kg and move at an initial speed of 3.0 meter per second on a flat road before braking. Braking happened mainly because of friction between the tires and the road. The coefficient of friction is taken as 0.7 for a dry road and 0.4 for a wet road, showing that wet roads have less grip. Air resistance, road slope, and tire deformation are ignored, and only friction is considered to control the braking force. Therefore, the car is assumed to slow down at a constant rate. The aim of this study is to compare braking performance on dry and wet roads in terms of deceleration and stopping distance. Newton's second law and kinematic equations are used for this analysis. The result shows that braking is less effective on wet roads and the stopping distance becomes longer, which increases the risk of accidents. Next, the methodology. The braking performance of a Pro 2 Asia was analyzed on both dry and wet roads using basic physics principles. The car was assumed to travel on a flat, smooth surface with friction between the tires and the road as the only forces slowing it down, while air resistance and rolling resistance were neglected. The vehicle weighs around 1400 kilograms and initially moving at 3.0 meter per second was considered to come to a complete stop. On dry roads, higher friction between the tires and the surface allows the car to decelerate more quickly, resulting in a shorter stopping distance. Conversely, on wet roads, reduced friction causes slower deceleration and longer stopping distance, highlighting the increased risk of accidents under wet conditions. The analysis focused on understanding how the frictional force influenced the car deceleration and stopping distance and comparing the outcomes for the two different road conditions. That's all from me. Thank you.
For the calculation part, we analyze the braking performance of a Produa Azia. The mass of the car is 1,400 kg and the initial speed is 3 meter per second. We compare two road conditions which are dry and wet road. For the dry road, the coefficient of friction is 0.7. Using Newton's second law, the calculated deceleration is minus 6.87 meter per second square. For the wet road, the coefficient of friction is lower, which is 0.4. Because of this, the deceleration is smaller at minus 3.92 meter per second square. Then kinematic equations are used to calculate the stopping distance. The stopping distance on the dry road is 0.66 meter, while on the wet road is increased to 1.15 meter. For the analysis part, the results are discussed based on both theoretical calculation and experimental observation. From the theoretical analysis, Newton's second law and kinematic equation are used to predict the braking behavior under dry and wet road condition. On a dry road, the higher coefficient of friction produces a larger braking force. This allows the car to decelerate more quickly and stop within a shorter distance. On a wet road, the coefficient of friction is lower. As a result, the braking force is reduced, leading to lower deceleration and longer stopping distance. This indicates that change in tire road friction directly affect the braking behavior of the vehicle.
Hello, my name is Muhammad Al-Habib bin Badri Sham. My number matric is DD240118. I will talk about discussion. Okay. First point is vehicle braking performance is strongly affected by road condition. Higher friction on dry roads result in greater braking force and faster deceleration compared to wet roads. The calculated deceleration was negative 6.864 meter per second on a dry road, mu 0.7, and negative 3.924 meter per second square on a wet road, which is mu equals to 0.4, leading to shorter stopping distance on dry roads. The stopping distance increased from 0.66 meter on a dry road to 1.15 meter on a wet road, confirming that lower friction causes longer stopping distance. Okay, the third one is this result align with Newton's second law and highlight the importance of effective braking system and cautious driving, especially under wet roads. That's all. Thank you.
Lastly, the conclusion for this report. This project examines the braking performance of a product Azia, which is the local Malaysian product, on a dry and wet road using a Newton's second law and kinematic equation. We show how friction directly affects deceleration and stopping distance. On a dry road, a car stops quickly with higher friction, while on wet road, reduced friction led to a slower deceleration and a longer stopping distance. This result highlight the crucial role of friction in a vehicle safety and the increased risk of accident under wet condition. Although simplified, the study reflect real-world behavior and demonstrate how classical mechanics can be applied to evaluate braking system. And overall, the finding emphasize the importance of causing driving in adverse weather and the value of engineering analysis in improving road safety. And that's all from us. Thank you.